All right. Cool. Let's get into it. So, we're going to be building a new application, new EVE app called Copilot. What's Copilot? All right. Well, first we need to start here. So, if you've seen this before, this is a project called React Flow. And what it does is it gives you the ability to build interfaces with these node-like inputs. So you can see here, we got a few nodes connected to this output node. And as we change some of the values, it changes the output. That's pretty cool. So this is going to be called node-based editors. Sweet. What's that got to do with anything? Well, if we scroll down, come on down here to the showcases, and we look at more projects, we're going to find this project called Data Blocks. It's actually made by the same people who make React Flow. And if we look at Data Blocks, what it does is it has that, it's a node-based editor. It's got that same type of interface, but it's specifically for exploring and analyzing, transforming data without code. Cool. So, here's the idea. Build a system that exposes a lot of the raw data from EVE's API, whether it's market data, system data, whatever it is, solar system data, character data, you name it. And instead of building specific tools for you to be able to explore that data and visualize it, like take for example, a great tool, I absolutely love this tool, Atom for EVE, right? Alright, well, whenever that decides to load, if you're familiar with Atom for EVE, it gives you tons of data. Their market trends, their market finder tool, one of the best. So you got these specific inputs. You can pick your region, whatever the case may be, and they give you some output here. You got each item. They calculate the spread, the percentage spread, the different prices, the average number of trades, the average ISK sold, probably over a 7-day average, I don't know. You got your 7-day buy and sell change in percentage, your 7-day buy and sell volume change in percentage. So you can get a little bit of a feel for price changes and demand changes, which is very cool. This is a great tool, but you kind of get what the developer gives you, and that's it. So for example, this particular developer does take feedback. If you want to if you want to I believe it's dev.atom for EVE. If you want to see some of the changes that he's made on the dev site, for example, he adds this competition section, which is very cool, in some various things. So it's not like you can't affect change on this tool if it's not perfect, but you can't do it so directly. You need to kind of go through the developer. So here's the idea, is give you the tools to build the tables and the data exploration tools that you want at the end of the day. Let's just look at an example here quick. And by the way, I'm not trying to specifically go after Atom for EVE. I'm just using this tool as an example. Hey, I want to offer promotion in your channel. Okay. Just trying to use this as an example because I personally use this tool all the time. Absolutely love it. But at the end of the day, if you want to really do trade in Eve, you're probably going to have your own spreadsheet, and this is going to be one of the tools in your toolboxes. Again, because it can't be all things to all people. All right, let's look at an example of data blocks in action. So here we go. We've got some example data. In this case, we're looking at UFO sightings, and you can see what this raw data is down here. So you got some years and the number of sightings in a given year. So then what we're doing here, I'll just redo this so we can check it out together. You can see you got input data. That's going to be your raw data. You can transform it. If it's geotype data, you can do stuff with that. You also got some visualization. The visualization we were just looking at here is a time series. So we connect that up. Okay, and then it's going to need to know what your x-axis and your y-axis is. So along the x-axis, we're going to want the year. That's already picked. That's great. And along the y-axis, we want to be looking at the sightings. And so you can see here, and sometime in the mid-90s, either we got better at seeing UFOs or they got more interested in seeing us. Who knows? And then in the late 2000s, I guess we both got bored of each other. So that's that. And this is a really simple example. Again, there's lots of different types of blocks that you can use to visualize and filter and transform your data. But at the end of the day, the reason why I like data blocks is because if you can't find what you want on the built-in stuff, you can always write custom code. And so you get that a little bit of a escape hatch there. All right, sweet. So that's the front end, right? It's like give you these data blocks to be able to process raw data and then build the tools that you want. Whether it's a market explorer, whether it's a solar system finder, whether it's a personal mining accounting system for your corporation. I don't know. Who knows? It can be whatever. All right. But it's going to need a backend. And for the backend, I'm looking at Phoenix. So, Phoenix framework. I think if you look at like the JetBrains most popular web frameworks from 2022 or whatever, I'm pretty sure Phoenix framework's at the top of the list. It's fantastic. It's written in a language called Elixir, which is also fantastic, but a little bit less known. Basically, if you don't know what Elixir is, it's built on top of a virtual machine called the Beam. And the Beam is the virtual machine for an older language called Erlang. Erlang came out, I think, in like the 70s. It was built for telecommunication networks. And the idea is that they needed to do a lot of massively parallel computation. It had to be simple to reason about. If you're familiar with parallel software, it can be a little bit complicated how memory is passed around between different CPUs, threads, and there's some complications with it. So what Erlang wanted to do is create a more simple model. So you get things like immutability out of the box. And you get essentially what is a process tree inside of your application. So your application is not one single process. I come from Node, so I'm used to an application literally being one single thread. But not the case with Erlang. You get lots of processes, and that's actually really powerful, because when you're dividing up your application in something like Node, it's tempting to want to create sort of microservices. And, that it was at least a huge trend. Now things are going a little bit in the opposite direction, but microservices are still massively popular. However, they're hard to manage. Honestly, you need to build a bunch of custom tooling, because every single person does microservices in a slightly different way. You're at least going to need to have somebody who really knows Kubernetes and can kind of build up a platform, because every microservice is going to need logs and monitoring and all kinds of, just the basic things that you look for when you're running an application. And then that sort of creates an operational issue when you want to create a new microservice. Many times you need to work with your operations team, your DevOps team, to say, hey, we want this new microservice. Maybe they need to spin up a new subdomain to point to that microservice. Maybe they need to spin up a new load balancer to balance traffic across various instances of that microservice and whatnot. So this becomes creating a new microservice a lot of times is a sort of joint operation between your DevOps team and your development team, that both are working together to deploy that new service. With Erlang, and specifically the Beam virtual machine, because it has this concept of processes and essentially what becomes like a process tree, where you have one root process that spawns many other ones, and each of the other processes can be responsible for one piece of the application, essentially a microservice. When you want to create a new microservice, it's simply another process within the same application. Your DevOps team, it's actually completely opaque to them. They don't need to care. They are worried about deploying your Beam application, and as long as it's running, it's all the same to them, whether there's one service in there or 1,000. The software architecture, how the application is broken up and divided into domains, is totally the responsibility of the developers. And in my opinion, that's the way it should be. Your site reliability team should be worried about whether or not the application is running, whether or not traffic can get to it, to and from, and whether or not the network is secure. And that's about it. They've got databases to monitor. They've got a lot of stuff to do. If you can take away the mundane tasks of setting up new subdomains and monitoring and logging or whatever for each little microservice that we want to launch, ultimately that's a good thing. So anyways, that's the Beam. And then we have Elixir on top of that. So Elixir is a modern language that runs on the Beam. So Erlang is the original one, and it is not very developer friendly, I would say. That might be a bit of a hot take, but I honestly think that that's one of the main reasons why Elixir exists in the first place. And part of the reason why it got so popular is because the Beam, this underlying process model, is super duper powerful. But Erlang was somewhat of a barrier to entry. So we got this guy, Jose, and he created Elixir. He comes from the Ruby community, created Elixir, and actually, like many things, he's one of the main developers at Phoenix and so on. But he created Elixir to be more approachable and to run on the Beam, to still take advantage of this underlying Beam virtual machine and this multi-process sort of application architecture in a way that is, in my opinion, a much more beautiful and approachable syntax. Okay, so then Phoenix is the main web framework on top of that. Think Express for Node.js. It is like the one that everybody just goes to. The documentation is absolutely incredible. In fact, the documentation across basically all of Elixir is incredible. So they use this site called Hexdocs. That's where you can go to read all the documentation for all the modules that you could want. So where are we at? I literally just started. What we have here is essentially what you get by running through the documentation and going through this install process. So we set up our Elixir environment. We're using Elixir 1.14. We're actually using Erlang 25, and then we install Hex, install Phoenix. Phoenix just released a new version, 1.72. They don't release new versions very often, so that's pretty exciting. It's got a lot of cool new stuff, so we're going to check that out. And then we just generated this project. And that's it. We haven't even set up the database. We're going to have to do that here in a second. We'll just continue on through it. Okay, so I did run Mix Phoenix Copilot. This is the name of the application here. So instead of saying Mix Phoenix new hello, I did Mix Phoenix new Copilot. Generated a lot of that code, and then yeah, you can cd into your application and run mix ecto create. That's going to configure your database. So we haven't done that yet. Let's go check out our database. So now look in config here, dev. All right, so we've got config Copilot. Username Postgres, localhost, Copilot dev. Okay, very cool. I have down here a Docker Compose. This didn't get generated. I put this here. And so we're gonna run Postgres. I guess we'll just do 13.6 Alpine for now. And we're gonna set it up with a Postgres user, Postgres password, and Copilot dev. And what we should be able to do then is to come into our terminal. Sometimes I'll use that terminal, sometimes I'll use this one. Doesn't really matter. It's all the same stuff. And we should be able to do Docker Compose up. I'm gonna tack on this -d here, because basically what that's gonna do. Oh, you can't see that. Hold up. Alright, well, for now I'm just gonna move my window like this. Docker Compose -d. And what that's gonna do is run Docker Compose, which will come into this file and see the services that we want to run. Pretty much that's just the DB. It's going to download this Postgres container, launch a new instance of it, and basically create a DB for us. And the -d here just means do it in detached mode, because I don't want it running in this terminal. I'm going to use this terminal for other things too. So I want it to basically launch and then run in the background. So, okay, what is this saying? It says it cannot connect to Docker. It's asking if Docker is running. Probably not. So we'll launch Docker here. And in fact, you know it's not, because when Docker's running, it's up here. So we'll wait for the whale to stop loading, and then we'll try again. Alright, in fact, I've got a couple other services right now. I'm going to just stop those so we don't have conflicts with any of the ports. The default port for Postgres is 5432, and what this is saying is it's going to bind the 5432 port of the container to the 5432 port of my computer, because basically what a container is it's a virtual machine. It's like a computer running inside your computer, and that virtual machine has its own ports and your computer has its ports, and what this is going to do is bind them together so that you can communicate between the virtual machine and your computer through that port. You could change the numbering, so I could bind 5432 in the virtual machine to almost any random port on my local machine, but then you got to remember that and it gets hard. I'm too lazy for that. I just bind them to the same port all the time. Alright, let's try this again. Alright, so it created the network, Copilot default, and started a container, Copilot DB1. I'm gonna just make sure it's running over here. Okay. So you can see in this Docker desktop, excuse me, I just reposition. See in this Docker desktop that our database is set up. Okay, very cool. Now let's come back over here and try doing make secto create. What is that gonna do? Well, with any luck, alright, database for Copilot repo has been created. Great. Alright. There's really nothing more to see there. I'm just going to close that. Now that we've done that, we should be able to run make Phoenix server. Okay. So build finished, launch for changes. This does live code reloads, like you're probably used to. Let's see here. It seems that my circle cam is going to be a problem. See if I can just like move me. Is that better? Hopefully that's a little better. Alright, we're gonna do one of these. There. That way it kind of looks like I'm looking at it. Alright. Cool. Select that back up. Sick. Alright. So we can see here it's running on localhost 4000. Let's go see what we get there. Alright, when we click on that, it launches this very default sort of view. We click here, that takes us to the documentation. And okay. Thought that would give me a back button. Let's try that again. Get text compiler is no longer required for mix. Okay. Alright. You also get this live dashboard, which is pretty cool. So if we come into here, we can see what version of Elixir we're running on, what version of Phoenix. This is not supposed to be 1.6.16. This is supposed to be 1.72. Alright. Let's figure out what's going on with that. And dashboard. Alright, hold on. We might regenerate this Phoenix project if it's on the wrong version. Yes. That is not the correct version. We want Phoenix 1.7.2. Why did that happen? Installation. Phoenix. Mix help, Phoenix new. Alright. Gonna run some of these things here. That is the right version. So now I'm wondering why it didn't give me that version when I generated the project. Alright, let's try this. We're gonna cd into a temp directory. Oh. Okay. Now we're gonna do mix Phoenix.new. Hello. Yes. So dependencies. This is not the plan. It's okay. Sometimes things don't go as planned. And actually, this is going to run a little differently because... Alright, I should explain this. I'm using this thing called ASDF. And it looks at a file here called tool versions to see what version of Elixir it should run. So when I'm in the directory for Copilot, it's running one version of Elixir. When I'm not, it might be using a different version. And actually, that might be what happened here. Yeah, alright. Cat, mix, cd hello, mix, x. Yeah, we're on Phoenix 1.6.5. Okay. So ASDF. ASDF list Elixir. Yeah, so we've got all these different versions of Elixir installed on our computer, on my computer. Let's see which one we're using by default. So that's the problem. We need to update that. Like that should be okay. Okay. Now, I want to tell it to use set the package global version. Alright. ASDF global. I'm going to tell it to use these versions here. Alright. Try that again. Mix, Phoenix, new. Hello. We're still in a temporary directory, by the way. Okay. We're gonna see what version we're on, and now you can see we got Phoenix 1.72. All right, that's what we wanted to see. Okay. So let's see, what do we have here? All right, we added our .m. We're basically going to try and delete all of the things created by generating Elixir. All right, so we're gonna rm dot formatter rm dash rf underscore build dash rf underscore build dash rf assets config depths lib mix. I'll do block. Oops. Alright, mix. Dash rf priv test. Alright, so now we just have this basic stuff. We've got our docker ignore, a editor config.m for putting environment variables, our git directory git ignore.idea, which is for my IDE here, that tools versions file, a license, MIT license, by the way, and readme and docker compose. Probably some of these will still get overwritten when we generate the Phoenix project. That's okay. Alright, so we're gonna cd up one directory here and try. Well, alright, first we're gonna just double check the version of Elixir that we're on here. So you can see we're on Elixir 14.4, Erlang 25. That's good. That's what we want to see. So now we can do Phoenix new Copilot. And what it's going to say is that the Copilot directory already exists. Do you want to continue? This is a great feature, by the way. There are a lot of projects that would be like, nope, that directory already exists. Can't create into it. Because they want to make sure that they create the directory and that everything's perfectly clean. Elixir is smart enough to handle it. If you already have essentially a empty Git repository or something like that, it can create into it, which is really nice. You just got to say yes. And if it finds conflicts like this readme, it's going to say, all right, this one already exists. Do you want me to override it? In this case, I do. Same with the git ignore. The git ignore, less so. I don't want to override that. I happen to know that it's already fine. Okay, fetch and install the dependencies. Yes, please. Alright, now we're gonna, while that's happening, we're gonna come here to Docker. And we're gonna open up the Docker dashboard. And just, like, delete the container that we had spun up before. Because that is no longer going to be one that we need. Alright. We're going to create a new one for this Phoenix application. So we're going to cd into Copilot here. And we'll do our Docker compose up-d again. Cool. Looks good. All right, so here we are. Container created, database created. Great. Next step is to mix ecto create. So that's just going to install some dependencies. Basically what Mix is doing here is it's running scripts. So ecto create is a script that I got when I did Phoenix New, which was also a script. Basically everything that Mix does is it's just a command line tool to run scripts for Elixir. And so I got this ecto create one when I installed Phoenix, and it's gonna go in and set up the ecto repo for us. I don't know what ecto is, by the way. We can check it out while it's doing this thing. So as I mentioned before, the Hexdocs is a site for documentation for essentially like every Elixir project out there. So that's going to include ecto. And ecto is a great project. It's essentially it's the go-to project for interacting with, especially like for databases, especially SQL databases. I don't think it's, well, it can do things like Cassandra or DynamoDB, whatever, no SQL databases, white column databases like that. It's really more tuned for SQL. And as we get into this, especially things like ecto query and whatnot, like you'll see what I mean. But it is essentially a repo library. So you can define your repo, say that we're using Postgres, so it's going to have this adapter so that it knows how to translate queries and things like that to Postgres. You can configure it to connect to your Postgres server. You start it up, yada yada, and then you can sort of define what ecto calls schemas. And so what this schema is doing is saying that there's a table here called weather, and it's got some columns, 4 at least in this particular case: a city, a low temp, a high temp, and a precipitation, probably percentage chance of precipitation. You can then instantiate structs like this, and when you're ready, you can insert that struct into your table by passing the struct into a function called insert on repo, and it's just going to know, because this struct was set up saying that it's part of the weather table. It's just going to know to insert this record into weather. Now, you might be asking about IDs, like how do they get auto-generated and all that kind of stuff, and there are conventions with that. Ecto is a little bit of a convention over configuration type of application, which I'm not a big fan of. Like, if you agree with their conventions, it's great, but I often don't. So I end up going in and configuring things. But the nice thing is that you can do that. You can configure it to basically be whatever you need, whatever you want. At the end of the day, it's a great repo. Really, really like it a lot. All right, so here we go. The database for Copilot has been created. That's great. We'll jump back to our Phoenix documentation here and just continue up. So we ran mix ecto create. Next thing again was Phoenix server. Alright, mix Phoenix server. Alright, we building. Done. Here we are. Alright, so this looks a little different, which is good. Definitely means that we're on the right version. Phoenix Framework 1.7.2. And I think under here they moved the dashboard. It used to just be /dashboard. I think that's, yeah, that's no longer a thing. I believe it is now /dev/dashboard. And you can actually see that, yep, here. So here we go. Under here again, you got your Phoenix version, your Phoenix version, your Elixir version of the dashboard, because this dashboard also is its own project module, whatever you want to call it. You can see how your memory is being used. If you're not familiar with what all these things mean, it's fine. We don't need that. We're going to be getting into the more interesting stuff in a minute here. Cool. I don't know if I want to enable OS mod, but this dashboard is also able to do things like monitoring your CPU usage and all that kind of stuff. It does do it by default, but you can set it up. I think we're not going to do that. Okay, so at this point, we're up and running, and I think we're our next step is going to be to set up live view. All right, Phoenix live view. What is that? This is another reason why I wanted to use Elixir and Phoenix, is because of this module here called Live View. Okay. Essentially, what Live View is, if I can boil it down, is it's kind of like React. You're gonna notice that you build components and you write HTML looking code, and you can inject, so they call them assigns, React calls them props. You can inject those into your HTML. Here's the sort of like the escape syntax where React just uses brackets to input variable names and all that kind of stuff. But it's like very similar to the idea of components in React. Now the difference is that these run on the server side, and Phoenix will generate static HTML for you, send it down to the client, and then as the data changes on the back end, it will send updates over a WebSocket connection to the front end and update your front end. Now, you might be thinking like, well, on the front end we were talking about using this data blocks thing, which is definitely a React-based project, right? So you can interoperate between React and Phoenix Live View. So we're gonna be doing that here, and that will basically, in my opinion, give us the best of both worlds. Now, the reason why I still want to use Live View is because I have this vision of as the data sort of updates on the back end, that we push that data down to the front end. React Flow or data blocks is going to be able to receive the updated data, reprocess it, and give you live updates to your visualizations. And just having the WebSocket infrastructure and everything already in place by React Live View, that's going to be really nice, I think. at the end of the day, that's the primary motivation. Let's go through the guide to just get this installed and get ourselves up and running here. All right. Forget what Floki is, but for test, add these depths. Phoenix Live View 1.18 came out pretty recently. I mean, I suppose in relative terms. Elixir projects in general tend to update slower than things like slower than what you may be used to if you're used to the JavaScript community, for example. But again, I think that's one of its strengths. They tend to just build it right the first time, so they don't need to update as often. A little bit of a jab there, but that's how I feel. Hot take. I'm just gonna move this Floki package down here since it is just for test. Sometimes I like to separate out the packages that are for different environments. So for example, oh, actually we already have LiveView installed here. Alright, so we don't need that. That's sick. Okay. Let's see if we've got in our config, let's see if we already have our endpoint set up with LiveView. What am I doing? Config. So here's our endpoint. We already have a LiveView salt. Very cool. We'll obviously move that salt to a secret later, but for now it's fine. And the following imports your web file. My app web ex. Alright, let's see if we're set up there already. Alright, so lib, Copilot web. What imports do we need? So we have this def view and router, live view router. Okay, we already got live view router implemented there and inside of. Okay, so we got live view, use Phoenix live view. We do not have a def or just straight up view, but I'm thinking that's probably okay. Alright. Check out our endpoint, make sure we got a socket live. Do. Alright, cool. So this seems to have set up a lot of this for us already, which is really nice. Alright, let's go check out our router, see if there's any live view pages that we can take a look at. Components here. All right. No live view pages yet. See if we can generate one. I don't know what generators are available and all that, because Let's see. I've not played around with LiveView too much. I am more of a backend developer, and we're going to get into that next. We're going to take a look at something called commanded. Interesting. I was kind of half expecting to see some mixed commands here. That's okay. Location for live modules, progress animation, layouts. You know what? I think the mix commands are actually part of Phoenix now. If I recall correctly, they have ways of setting up authentication for you straight up with just a mix command. And I think if you add the -live argument to it, it will generate it as a live view, which is pretty cool. Two different ways: using live view, using controllers only. Ports live view for enhanced UX. I don't think we want to use authentication just yet, though. Mix tasks. What else we got under here? So generate a live view. Okay, mix fiend gen live. Let's take a look at that. Okay, sweet. No documentation for that. That's cool. That's alright. Let's see what we can figure out here. I might... Yeah, we'll just stop the server while we're generating these live views. Alright. Let's Phoenix generate live. See what we got. Floki is duplicated at the top level. Alright. Well, we don't want that. Where's Floki? Ah, it is already there. Alright. Maybe Simi, you caught that. If so, nice work. Alright, so it's giving us some examples of how we want this to be used here. And basically what this is going to generate is going to be kind of like a form view for creating users. Maybe we want to call this data blocks. I haven't even thought about this at all. Mix, Phoenix, gen. What do we want to call these? Just call them blocks, call them routines. I'm going to call them blocks. That's going to be inside of A. domain, here they're calling the domain accounts. You create a user inside of the accounts domain. We want to create a block, but I don't want to call it like the data domain. That's not great. Maybe we come back to this. Honestly, maybe we come back to this. Let's make sure that we're all set up here. Just double check things that we've added. Yeah, some test files, mix files, a bunch of lib files, config files, some assets, icons, lots of icons. All these hero icons, they come from the Tailwind community, which, man, I gotta say, like, that is an impressive project. So formatter, git ignore, readme, assets. Okay. Sick. All looks good. Reads and Phoenix project. Push that up. You might be wondering, is this going to be open source? And the answer is yes. I'm just not sure how exactly. I do kind of want to just be able to move for now. And sometimes, especially early days with open source projects, if you're developing them like I am in the open, you get a lot of input. People will make MRs, and you gotta sort of manage the expectations about what MRs get merged and don't, because they can, the early ones especially, can dictate the direction of a project a lot. So yes, it will be open source once, I guess I'll say, it gets its feet under it a little bit. Okay. Next thing we want to do. We want to, oh man, let's create a web domain. I really don't like that. I really don't like that. Maybe it's okay. I forgot that it creates web domain in its own, like, side directory here. It does seem kind of clean. Separates sort of the back end from the front end, but I a lot of times just combine them because for me it's easier. But we'll roll with this. Alright, so we have our application here. We create a new domain inside of our backend portion called commanded. That's going to be the next thing that we talk about. Just make sure we're still listening to some music that we're allowed to listen to. Don't want to have any issues with copyright. Just so we know what we're listening to. It's Ignition by Stream Beats. So there you go. Alright, let's take a look at commanded. Looks like we got a couple songs left on that album. I'll find a new one. Alright, what is commanded? This is much more up my alley. Commanded is a library for building CQRS event source applications. What does any of that mean? So let's start with event sourcing. Event sourcing is super cool. And in your typical application, what you're going to find is you've got your SQL database, and it is where all your data lives. You sort of model your reality. You know, if you create a user, you model what a user looks like. It's got a name, first name, last name, maybe it's got an address, it's got an avatar photo, all that fun stuff. And you build a table with those properties, and that's where your data lives. If the user changes their name or their email or their username or their address, whatever it is, you go and you update that row in the database. I mean, that's how I've built applications for most of my career, until I found event sourcing. Now, event sourcing is not a hammer. It should not be used for everything. It has its time and place. I do believe that what we're doing here is a good use case for it, and I'll get into why in a minute. But first, what is it? Event sourcing, instead of creating a user table and then inserting and updating into it, instead what we do is we capture every event that happens in our system. So we don't have a user, we have an event that user was created. And then if they change their email, we don't update the user. We store a new event saying that user email changed or user email update. Like, you can name the events whatever you want, but the point is you're creating essentially this log of all the events that happen for that user. So they were created, they changed their email, they changed their name, you know, maybe they deleted their account, right? So you've got these events, and the idea is that you can look at each of those events in order and always know what the state of that user was at any point in that timeline of events, which is pretty powerful. Let's say that, you know, you wanted to build a very common real world example of this is accounting. If you're familiar with accounting, you've got your transactions, and so you put money into an account, you add more money into an account, you take some money out. Well, you don't just simply update the balance each time, because maybe the balance is, you know, $1,000, but how do you know if it's right? Well, you know it's right by looking at all the transactions, because those are essentially the events that affect the balance. And without the transactions, you would look at the balance and be like, well, it says it's $1,000, but I don't know if that's true or not, and I can't kind of go back in time and see how we got to $1,000 or anything like that. That's why accountants use what's called a ledger, where they keep track of all of the transactions. Event sourcing is kind of like that. Instead of a ledger, we call it a log or an event store, and inside of there we have all the events. Okay, and then the balance is just the result of processing all of those events and outputting some data. Whether, like I said, if these events are user events, maybe you look at the event created, the email updated, and so on, and you output the state of the user at the end of it. If they are transaction events, you'll sum up all the credits and debits and then output a balance. That output is called a read model many times. It's got a few different names. Sometimes it's called a projection. In a nutshell, that's event sourcing, and it's quite powerful because you don't necessarily need to get your data model 100% correct. You can simply capture all the data in events, and then you create your projections, your read models, using those events. Now, the events are immutable. They don't change. So if you do have a data model attached to your events, that's got to be correct. It turns out that in a lot of ways is the easier problem to solve. And that's going to be the case here for us because we are interacting with EVE's API. So the Easy API. What am I talking about? The Easy API. EVE created this Q acronym ESI. I saw the spec somewhere. Let's see. Well, I don't know that this gives us the spec, but you can read all about the introduction to Easy. I think it stands for EVE Swagger Interface. So Swagger is a documentation tool. It's open source. Check it out. It's great. Super popular. And so EVE is using that. Very nice. Thank you, EVE. We love it. And then this, I don't know if EVE put this website up or some other community member, but this essentially takes that Swagger documentation and creates a website where we can go read the docs. All right, so let's see. Industry. There's going to be industry facilities. Market. All right, let's look at market. We don't want to look at character. We want to look at region orders, let's say. Okay. So we have this documentation, and it's going to specify the parameters that we can put in. But more importantly, it specifies the response data. So we can see the duration is a buy order, when it was issued, the location ID, and all these various things. So first of all, like modeling our events, we could just model them after the specification that we have here. We could also be even more flexible and just say, we don't really care what you give us. We're just going to put it inside of a JSON blob, stick that in our event, and just call it a day. I might go that route. And then that way our event schema really never needs to change. It's literally just a JSON blob called data. Whatever data we get out of the Easy API, we store in our event. And then we can build our read models off of that. If maybe EVE changes their spec under the hood, then we just update our read models. Our events schemas don't need to change at all. We don't need to worry about database migrations. We'll get into all of that as we're building this up, but because our strategy here is basically capture data and then figure out what our read models look like, there's this natural separation between the data coming in and the data going out in our application. And that leads me to the next topic of conversation, CQRS. So what is CQRS? It stands for Command, Query, Responsibility, Separation. And the commands, as we'll see, are essentially data coming into your application. They come into your application in the form of commands saying, I want you to record this data, or I want you to update this user's email. I want you to create this user. And essentially, they are intentions. They're called commands, but that sounds a bit forceful. They are really requests almost. They're saying, I intend for the application to do this thing. Now, the application is going to verify that that thing is allowable, right? So it might be the case that you're telling it to do something that it's not in a state to do. You can't create a user with the same username as some other user, for example. That's going to be an invariant in the application. And so if you give the command to create a user with the same username as another one, it's going to say, I'm sorry, no, that's an error. You need to try a different username or whatever. And so the commands really are more like intents. And that's one whole side of the application, is literally just receiving intents or commands, verifying that they are allowed, and then recording them. The way that it records them is it records them as events. So actually, let's kind of visualize this a little bit. There's this tool that I like to use. I think it's called Excalidraw, something like that. Excalidraw. All right, so we're going to visualize what's going on. We've got a command here, and the application is going to use something called an aggregate. We're not going to get into exactly what an aggregate is just this moment. We'll get into that a little bit later. But for now, suffice it to say is the aggregate keeps track of the state of your application. And so you use it to decide if the application is in a valid state to receive this command. If so, you will record an event. If not, you will simply produce an error. So this is the valid case. You give a command, the aggregate says it's all good, you record the event. You don't record the command. You actually don't care. Like, once this command has been issued and the event has been recorded, forget about the command. It doesn't matter anymore. The event is what matters. The event is the data. So again, this is one side of the application, is receiving commands, validating with the aggregate, and recording an event. So going back to our CQRS, that's the C side. Now, what happens to events? Well, I'm running out of shapes. I'm going to use a square again. Events, then, here, we're going to try to make this one more square-like. Commands are rectangles. Events, then, get projected into view models. Okay? And you're able to essentially query your view models on the front end. I think for that, I'll just draw a little person here. That's our user. Great. Beautiful drawing. Our user is able to query those view models. And the separation essentially is right here. All right, so when they're talking about command query separation, they're talking about this line. The application is decoupled at this level, so that the view model is its own separate side of the application. Events get projected into them, but other than this one pathway where they are coupled together, where events are being projected into view models, The responsibilities between these two sides of the application are completely separated. And that allows you to scale up one side versus the other. It allows you to do nice things regarding the security model. You might have more security over this side of your application, where this side might be more public. That's certainly going to be the case in our application. Ingesting data is going to be something that maybe only administrators are allowed to do, while viewing those viewed models will be public. Let's get some music. All right. So that is that. Cool. So for all of that, we're going to need commanded at the end of the day. That's the moral of this story. We're going to need commanded. So let's set it up. Go to guides. Getting started. You're going to want commanded 1.4. Fine. I'm just going to check these things down to the bottom here. Whoa. Thank you, GitHub Copilot, but actually no thank you. We're also going to need JSON. Cool. We're going to need some more stuff, but let's leave it there for now. We'll run mixdev.get, which is going to install those for us. Duplicated. JSON is duplicated. We already have it. Okay, well we've got it there at 1.2. Let's bump up the version now. We want 1.3. Cool. Cool. All right. Then we set up our application. Elixir has this convention. So what we have here, each file basically has a module. And you'll notice that these modules over here are inside of the Copilot directory. These ones down here inside of the Copilot web directory. Okay, so the convention is that modules follow sort of the directory naming structure. So here we're inside of the Copilot directory looking at the mailer file. So the module name is going to be copilot.mailer. Here we're inside of the Copilot directory inside of the commanded file. So copilot.commanded would be what you expect to see for the name of this module because of where it is. Our OTP app is going to be called Copilot. This application, by the way, I was mentioning before in Erlang how there's many processes inside of a Beam application. This is what I'm talking about. So think about this as the root. It's like the first process, and then it's going to have many child processes. So it's going to have the telemetry for Copilot Web. It's going to have the Copilot repo process. It's going to have PubSub. This is where we get those WebSockets. Finch, which is for making HTTP requests. Our web endpoint. so far, these are all of our subprocesses. Now we're adding commanded, and you can think of commanded as a service inside of our application. So we're going to end up adding that as its own process here soon. Okay. First, we need to choose an event store. We're going to be using the Postgres one. There is a special purpose-based event store for event sourcing called Event Store DB. So just to avoid some confusion here, when people are talking about the concept of an event store, which is going to be a place where all your events live, they will often refer to the concept as the event store. If they're talking about the actual database called event store, they will refer to that as Event Store DB. So Event Store DB is the product. This one here, if I say event store, I'm talking about the idea. Okay, we're not going to be using Event Store DB. It's great, honestly, but in terms of our application architecture, we want Elixir and Postgres. That's just going to keep things simple for us. So that's why we're going to use the PostgreSQL event store. Cool. All right. So the commanded event store adapter. Read the documentation for the latest published version. Okay. Get started. So I'll add this to our deps. Oops. So it wants us to create a file here called eventstore.ex, and instead of my app, it's going to be Copilot.eventstore. The OTP app is going to be Copilot. Sweet. Now, don't get confused here. This is confusing. I really wish they wouldn't do this, but they call it myapp.application, which you can see is use commanded application, right? Okay. Look at the way that we set this up. Use commanded application. So ours is not called Copilot.application. That's this one. This already got generated for us by Phoenix. The Copilot application, again, that's going to be the root with all the children. Our commanded application is going to be called commanded. It's not going to be called application. A lot of times in the commanded documentation, they call their module application. So just be a little careful of that, is all I'm saying. All right, so we're going to copy this and come back to our commanded application, and this is what we had before, and this is what they're saying we need. So commanded event store adapters, event store, and then our event store is called Copilot event store. All right, beautiful. That's our new setup. Now we have our event store configured. now we need to go into our dev config and add all of these things. Let's go into our config directory, find our dev config. Alright, so here we have our repo. I'm gonna keep that there and add this one. My app becomes Copilot. That's our OTP application name. We're going to use commanded serialization JSON serializer. Postgres. That's all fine. I'm going to put these things in the same order just so it's like a little bit more sane. But we got our hostname, localhost, database, event store dev. So we're gonna have just one SQL Server instance running. Are you gonna get the config too or no? We're gonna have just one SQL Server instance running, but it's gonna have two databases inside of it. It's gonna have one for our main repo, which is where all of our read models and things are gonna live, and one for our event store. I just want to see if this will auto format this because I really don't like the way the indentation is, and I don't want to do it by hand. I'm lazy. One second, getting the call. Alright. Alright. It looks like I fixed it. Sick. Love it. Don't have to set that up then. Alright, and then we're going to add the event store to our main config file as well here. Let's do that. Also just going to put it down here. So you can see we've got our actual repos. You can have many. For now, we just have that one. And we're going to add this one to have our event store. So let's go grab Copilot event store. Come back to our config here. Boom. And just to be consistent, I think I'm going to go like that. I think that's more beautiful. Okay, that should be it in terms of the configuration. Now we're going to create our event store by running these mix commands. Now we got these mix commands when we added this dependency here. It's one of the really cool things about Elixir. It's like the packages are able to also install some of the sort of the maintenance commands, I'll say. So instead of your DevOps team needing to figure out what the package author intended, the package author is able to provide your DevOps teams with the tools that they intend for them to use, which is like, in my opinion, a much better way. All right, so database key not found in this thing. All right. So that could be because it's not running the proper mix environment. notice that we have it set up for dev here. Let's try this again. Nope, it was not that. Not found in pool, OTP app, enable hard deletes, false. Oh. Well, oops. That's why, right there. Gotta be careful. Copilot event store. Copilot event store. Alright, everything else looks good to me. Cool. Event store DB set up. At this point, I think I want to set this up. Here we go. This is going to let us explore our data later on. We'll call it Postgres localhost. That's all. Actually, I'm going to call it Copilot localhost. Might have many of these later on. Okay. That's our connection. Everything looks good. Cool. I don't really need a console right now. So we're going to check these two. I actually don't really care about that one. But whatever, we'll keep it checked. We'll grab the default schema for both of these. Let's see. Alright, the tables inside of here. Literally just schema migrations. That's fine. We'll get into what that means later. Tables inside of here. Now these are the tables for your event store. By far the most important one is events. We're not going to visualize it that way. There's no data in any of these. So we're just going to look at the columns. Each event has an event ID. It's got a type. So this type tells you, is this an event for a user being created? Is this an event for an email being updated? Is this an event for a transaction being recorded? All that kind of different stuff. So that's going to be your event type. There's causation and correlation IDs. We'll talk a little bit more about that later, but a lot of times what you'll have is a series of events that kind of fire off as a series of like action reaction type of thing. And so you'll have one event causing another event, causing another event, causing another event. And you can keep track of that chain using the causation ID. And then each of those events in that chain, they're also going to share a correlation ID. So this correlation ID will be the same for all of them, and you can use that to kind of group them together and see the group of events that kind of resulted as the root cause fanned out into all of the other events. Those events will have the same correlation ID, and you can see which one caused the other by looking at the causation ID. Then you have data. This is just a JSON blob, and it's actually just byte data. It's very, very generic because this table is not going to be opinionated about what the data looks like. Metadata. So You can also add metadata about your events. Pretty useful sometimes. And then ultimately you're going to have when it was created, because the order that events are created is extremely, extremely important. Okay, so that's all we're going to look at in terms of the columns for the events. And actually, we're just going to leave the rest of these for later as we come up, as we need to take a look at them. For now, they're really not important. The events is about the only one that's important. Cool. So I'm glad we were able to look at the database. At this point, we have configured commanded pretty well. We set up the event store. Let's just continue on. Alright, so now they're going to go through how to use the commanded module. I believe we are missing one little piece, and that is telling commanded to run with the rest of our application. That's not in here. I do have an example of that already in a different repo. So I'm just gonna go find that quick. I'm doing this off stream because it's not something I can share. But the whole repo, that is. This one piece of configuration though it's not a big deal. It's not private. Okay. I need to change. Yes, okay, found it. Telemetry, repo, pinch. Okay. Yeah, so setting this up into our supervisor is literally as simple as coming to our application here. And we're going to do it after pinch, but before the web endpoint. Oh wow, look at that. So smart. My goodness. GitHub Copilot is incredible. Cool. Let's see what else we got here. Everything else looks pretty good. Alright. All that is fine. Let's look. I'm just going to compare a couple things here. Commanded now. I have a few other configuration things set up over here in this other project. We're gonna leave them for now. Our event store looks fine. Okay, the last thing that I'm going to do is set up just some of the boilerplate that we're going to need for commanded. So I created this commanded directory, and immediately we need to set up something called the command router. Now, what is this? It is the command router is what tells a given command where to go in your application, right? So this is generating some examples for us. But what you can do is you can say, all right, if you receive the, all right, you can basically set up a composite here of different routers, so that you might have one for user commands, one for to-do commands, and so on. And we'll set that up later, but for now I just want to get this file in place. We're also going to need a type provider. I'm going to stub this out for a minute. I'm not going to write any code in it, but def module copilot dot commanded. Again, it's going to start with this because that's the convention. We're inside of the Copilot directory, the commanded directory. And then our file is called type provider. So interesting. I don't know that I want that. I mean, maybe. I'm just gonna leave that empty for now. Okay. And then lastly, I want to simply add a couple of helper modules. So we've talked about a command. I'm going to create a helper module for defining commands because there's some boilerplate, and we can extract that boilerplate so that we don't have to write so much each time. I'm going to call that helper file for commands the Copilot commanded command. And here's going to be a boilerplate. We'll start out with def module Copilot. Paste all this in. Alright. So converts module into a Z struct. Oh my goodness. I don't want to have alright. Got a little documentation here. It converts a command into a Z struct. And that's going to basically give us this schema keyword, very similar to like ectoschema, but in my opinion, it's a little bit more powerful for defining things like commands, because I come from the JavaScript world, and in the JavaScript world, we had projects like Joy and Yup for schema validation, that basically were able to take JSON and decide whether it was formatted correctly or not by looking at all the keys. Does it have all the required keys? Are all the types of those keys valid? Elixir doesn't really have, or didn't at least have, something like that. So I created this project called ZBang, and it's a way for you to define structs and define their schema. So you can define all the keys of a struct and their types, which is pretty nice in my opinion. Okay, and then this is just going to make sure that you are giving it an aggregate identifier. It's going to set up the Z struct and all that. We do not need to get into that right now. We'll talk about aggregate identifiers later. For the moment, I think I'm just going to march on. Add our next helper, which actually is for the aggregate. Replace this with Copilot. Alright. This is for helping set up aggregates. again, we want to use zstruct for defining the struct. And we also want to make sure that it's JSON serializable. Sometimes aggregates get stored in the database, and in order to do that, they need to be JSON serializable. Finally, we want to set up a helper for defining events. So this one, similarly, make sure that you define an aggregate identifier. We'll get into that later. Also make sure that it's a zstruct. Events are always stored in the database, and then they need to be JSON serializable. That's what this does. And that's about the extent of our boilerplate. Alright, we're just going to do a couple things here. Makes format. Makes compile. I like to add this all warnings flag on there. Sometimes Elixir tries to not be annoying, and basically if they've showed you a warning before and you haven't done anything about it, it won't just keep showing you the same warning over and over again, which is like, okay, thanks for not being annoying, but sometimes I need to see all the warnings. You can add that flag. Okay, and then finally next test. I don't know if these tests are going to work or not. They should, because we didn't really do much. Hopefully the tests out of the box just work. My goodness. Alright. We're getting close. Alright, we got an error here. Could not start application Copilot. Shutdown failed. Failed to start child. Copilot commanded. Failed to start child. Copilot event store. Expect serializer to be configured. Okay. So let's see here. This is probably going to be we need to configure it for our test environment, we can know that if we run Phoenix.server, if this runs, so this is running in our dev environment, and you'll see it's able to start up just fine. If we go over here, I think we can go to the dev dashboard and see our processes. But we should be able to see everything in here. We should be able to see the commanded. All right, so here's Copilot commanded, so that process is started up. And let's see here. You can see that this process has the Copilot event store. So all good, everything is running fine. Copilot event store running. Okay, so our processes are running. So remember before when I was saying about the microservices? These are essentially all the microservices. They're processes in Elixir, but microservices that are running right now. Like it gets pretty complex pretty fast. Now, unfortunately, we don't need to worry about every single thing, but like, for example, we have our event store pub/sub microservice running. We've got the live view channel microservice running. There's a code reloader. Obviously, that's not a microservice that you would find in a real architecture, but still, there's many things running here that we are able to run as a process, and I really love this model of basically moving a lot of the architecture into the application layer. So in many traditional, let's say you were building traditional applications, let's say you're building it with Go or Node or something like that, Java even, a lot of this architecture would be moved down into the infrastructure layer. So you can think of architecture as being sort of fluid in that way. Like some of it can be baked into your infrastructure, some of it can be inside of your application. And I used to think of those as two distinct types of architectures. You got your application architecture and your infrastructure architecture, and the two need to meld together. So they are coupled, but nonetheless separated. Erlang, the Beam in particular, kind of broke that illusion for me. And now I see the application architecture as all one thing, where some of it lives in sort of the code level. I'll call it the application level, and some of it lives in the architecture level. So our architecture level, or our infrastructure level architecture, is basically two things. You've got the Elixir application, and you have the Postgres server. That's it. Now, later when we deploy this, there's going to be a little bit of networking, infrastructure, and so on. But the rest of the architecture lives in the application level, which is beautiful. One of the absolutely best things about the Beam, Elixir, and all that. Okay, so what did we just do? We were able to verify that command is running here, which is great. Alright, Copilot. Sweet, this is what I was hoping for. Yeah, this is a better visualization. So here's our Copilot application. And so we start out, we've got a supervisor. The supervisor, basically what it does is it's the process that just watches the other processes. And so inside of our Copilot, we've got our repo. We've got a pub sub supervisor, which is monitoring a connection pool, or monitoring, sorry, pub sub, which has partitions and all that kind of stuff. Finch mentioned that was for making HTTP requests and all that kind of stuff. We've got commanded, which has our event store, a local pub sub, all this great stuff. We have our web endpoint, which actually has a bunch of things. Live view socket, a few other processes. You can kind of explore this, but this visualization gives you a really high level just view of what the tree structure of your processes are inside of your application. Pretty useful. And you can learn things by looking at it. You can kind of see the infrastructure. And so here we've got a local pub sub, and it's divided out into 7 partitions. Maybe you need more, maybe you need less, but by default it's actually 8 because it starts at 0 through 7. That's 8. But yeah, just wanted to show you that so you can see what we're working with. Anyways, the point is that our event store is absolutely running here, right there, and it's fine. So why are we getting the error that we were seeing when we were trying to do mixed tests? Well, that's going to be because it's not configured inside of our test directory here. So you notice that we do have the Copilot repo, but we do not have the Copilot event store. So let me just quickly see how we want to configure that. Again, I'm lazy, so I'm just going to see what I did before. Kind of do the same thing again. Okay. So for the test environment, we are actually going to use a different, there's a third option here, and that's the in-memory store for tests only. Let's click on that and see about setting that up. Alright, so we've got our config here. Alright, my app becomes Copilot. App here is going to be commanded. Right? Maybe. I think so, actually, yeah. Copilot event store. But for test. You may replace or omit the serial laser configuration. Alright, then this is talking about setting out test cases. We'll do that later. But for now, this should give us what we need. So now it's not going to try and load up this Copilot event store. That's basically being overwritten here with this in-memory one. So, let's see if that gives us what we need. Cool. Oops. format. Compile all warnings again. And then mix test. I just run these things every single time before I do a commit. Let's see what we've got. Alright, so we've updated the mixtx and the lock file. Added a few commanded files, updated the application file, updated the config files. Just make sure it's all fine. Okay. We're gonna do setup command. That's mostly what we did there. Cool. All right, I think next, that's probably actually going to be all for today. So next, tomorrow, what we'll do is maybe we'll start to look at integrating that React library, data blocks. I think before that, actually, maybe we need to look at ingesting a little bit of data. What's the point of having a front end that is not able to even use any data? So that's what we'll do. Next thing we're going to do is we're going to ingest a little bit of data. That's going to involve setting up a client on our back end to talk to the EVE Easy API. We'll see how easy it is. Get a little bit of data stored in our event store, and I think if we can get that far, that'll be a good next episode. All right, if you tuned in, thanks for watching. I doubt anybody's watching, but that's all good. We'll get there. Cool. Thanks, everybody. Take it easy. Bye.